feeling somewhat lethargic. I think thanks. Most of North America is under a heat watch or some such thing. So except for the winter storm warning up in the far northwest or something. So a little bit of everything. All right. Good afternoon, everyone. Welcome to the Thursday, January 20th HamSCIence Zoom conference. As I said in our meeting invite, we've been kind of hit or miss a little bit lately, and that's I think the way it goes with summer schedule. So it's just to be expected and whatnot.
I think it's June 20th.
Yeah, it is June 20th. Guys say look at the right computer.
Yeah.
Is it today?
Yep.
So the days start getting shorter tomorrow for us in the Northern Hemisphere. That's right. But,
happiest day of the year for an astronomer.
How's that, David? Why is that?
Yeah.
The nights get longer.
Ah, okay. Unless I guess you're a sun watcher, though. Maybe the sun watchers are happy that's unhappy. So, all right, a couple of things I thought we could talk about a little bit early on. Mary Lou, did anything great or earth-shaking come out of the Living with the Star conference a couple of weeks ago?
Well, we learned all sorts of different stuff, but I thought I'd show you just a little bit about what the conference was like. So if I could find it here, let's see. Share screen. That one. So here's just a little bit I put together for my local astronomy club about the Living with a Star NASA grant conference that was May 29 and 30 in Boulder, Colorado. So LASP has a whole building. It's on Innovation Drive, just a little turnaround, so they got to name it. And then they got to pick the number. I thought that was sort of fun. They're at 1234 Innovation Drive. Whatever. Laboratory for Atmospheric and Space Physics. So here are some of the people that I enjoyed talking to. Dolores Knipp from Boulder and Anthea Koster from MIT Haystack. I was very pleased and kind of amazed at the number of women in the room. It's not so common in physics meetings. This is a team of teams group. There are seven different teams. So Chen's group from University of Texas in Dallas. And they, in fact, were not there because there was a huge thunderstorm with big hail and whatnot the previous day. So their airplane was canceled and they closed the airport. So they were there by Zoom. Anthea Koster, as you saw from MIT Haystack, was there in person. Nathaniel and we are all part of Lynn Harvey's group, which is out of LASP at Colorado. And we also have several other groups in we have a kind of a varied group, not just all at one particular place. So there's the UAF, which I thought was the United Air Force, but it turns out, no, it's not the United States Air Force. It's the University of Alaska at Fairbanks. Oh, well. And then Arizona State. Then there was Yeoman Kim's group from NJIT. Gareth knows all about him. The Maruyama group from Colorado, the Maute and Liu group from Colorado, and Kevin Pham's group from Colorado at NCAR. So they were, it was very Colorado heavy, but it was interesting to meet all these people in person. I also learned some other things. I got to meet Joe Huba, our ionosphere modeler, who makes the pretty layers in the ionosphere that then the ray tracing can bounce off of. There was a lot of discussion about the big geomagnetic storm that had auroras, the 100-year storm that was 10 to 12th May this year, which we're calling the Mother's Day storm or the Gannon storm or the Mother's Day / Gannon storm, because Jennifer Gannon, who was one of these groups, died at about that time. I learned a whole bunch of more specific days that I am really interested in now following up. Days when something was very large or very small. So I have a list of days. Very happy that Nathaniel was able to report and JP that the Super Darn Radar's results, both north and south hemispheres, have now been analyzed in the same fashion for the years 2010 to 2021. It's a whole ton of data. Nathaniel can say something more about that. I gave a little spiel about ham radio contacts. Yay, ham radio. Large-scale traveling ionospheric disturbances and possible drivers of them. So this was my graph here on the right-hand side. I divided the 6 types of drivers that Diego and I had studied into 2 groups. Meteorological things are the blue dots, and those are things that are various kinds of winds, like the polar vortex and whatnot. And then the other kind are geomagnetic things, things having to do with magnetometers or various measures of the ring currents going around the Earth's middle. So we have the months of the year across the bottom, and find that the meteorological ones are very strong, especially the polar vortex in January, February, and then also at the end of the year, October, November, December. They dominate in those months. Then the orange ones, the geomagnetic ones, appear when the winds are less strong, and they are mostly in the summertime. There are 3 months in which both are significantly strong. One is March, which is the equinox. That's a transition month. Another one is September, which is also a transition month. Can I get this to show you? There's September there, when we're going from this to this. And then there's their midsummer spike here, which is still our mystery. We have no idea what's going on with that one, really, at all. So I thought I'd show you
Mary
some of
Lou?
the, yes?
The vertical legend, do you really mean percent or do you mean fraction?
Good question. What do I mean?
1% doesn't seem like much of a correlation.
Duh, that's very bad. That's fraction. So 1 is
Thank you.
100%. Yes, good point. I shall have to change that. Yes, sorry, that's very silly. And what it means is that for each individual day, so I looked at each individual day in each month, and like for the month of January, each time there was an LSTID, it could have been triggered by a polar vortex that was strong on the same day. So 100% of the days, poof, we got an explanation. Yes, it's certainly, sorry, fraction. Good catch. In the building where we had the meeting, the last building, the lobby was full of models of spacecraft and also one real spacecraft. So this one was the Mariner 7 spacecraft to Mars. They had built an extra one as a spare in case the first one came to difficulties, but the first one went just fine. And so this one ends up in the lobby. So I was able to reach over the cord there and touch a real spacecraft. That was very cool. Here's a longer view in the left side of the lobby, and you can see there are rockets, sounding rockets attached to the ceiling, and then at the very far end is that Mariner 7. They also had, I thought, a very interesting thing. They had these laminated wood boulders that you could sit on in the hotel, and so it was very, very nice. So I'm sitting on a boulder in Boulder.
Mhm.
Then we went to the National Center for Atmospheric Research. NCAR is halfway up the Front Range cliff of the Rockies, and it's this wonderful exotic building built by I.M. Pye, a famous, well, this made him a famous architect at the time, and it looks kind of like a medieval castle with these towers and lookouts and things. But anyway, here's some famous people in front of the entrance to it. JP is one of our students, and then there's our noble leader in the light blue shirt. Yay.
One thing about that photo, notice on the left-hand side, the number of bicycles. Do you remember what the hill was like in that driveway to get up there?
Oh man, those people, I don't know how they got up there, but going down, they just sort of flew at like 100 miles an hour off the end of it.
Yeah, they're dedicated in Boulder. They ride everywhere and even uphill.
All right, I thought that was pretty amazing too. So there were a lot of people on bicycles everywhere in Boulder. In the lobby, they had lots of exhibits about solar solar eclipses here on the right, and space weather, and all sorts of things. That was very interesting. And we went in the library and looked at their display in there as well. And they were also having a meeting for people who were college teachers at small universities, often minority serving. And Nathaniel will tell you what he learned about that. But anyway, then we went to Panorama Point. We had rented a van, and so Nathaniel and I were the professors, and we had these 4 college students with us. And we went and looked out on this point, really beautiful. You can see all the way across, almost to the edge of the world. So we're looking east here, and Gary, you should know that far, far, far in the distance is Cleveland.
And
Oh,
did you find proof that the Earth is not flat up there? Hopefully, right?
Yes, we could not see Cleveland, so I was just in that part. But this is the other end of the Great Plains. You know, Cleveland is the start of the Great Plains. This is the other end of the Great Plains, and then it just rises up in this huge, huge mountain. And then there's the foothills, which are not what I think of foothills as kind of mild, sort of hilly things. No, these were mountains already, and then behind them, big mountains. So you could look out, and behind the branch here, I'm sorry I didn't arrange this very well. This is University of Colorado at Boulder, is this lump of stuff here. And this stuff over here is partly a large hospital, and then something else as well. At any rate, it was very, very picturesque, and I'm very glad that we got to do that. And then here's on the way to the airport, is the only time I got to see the distant mountains. So here's the foothills here that we were in. And then here's a snow-covered mountain in the distance. So it was really cool at the end of May to see totally snow-covered mountain. That was exceedingly exciting. They also have, when you look back toward the plains, everything is very flat. And then you get these huge, huge clouds. So here we're coming up on a road, and it says the road ends. Oops. Means suddenly there you have to make a choice and go either left or right. And this person had pulled over to the side of the road to try to decide, should they go left or right? We went past them and turned right, whatever. And then you have these enormous, enormous clouds. And on the last day we were there, on the way to the airport, we saw what we thought was snow on the ground. It turned out to be hail. There had been hail the night before. So they had really huge updrafts in these clouds. And there's the Boulder the Denver airport. So we had to drive from Boulder down to Denver and get the airplane there. Very unusual looking terminal complex there. The actual tower where they look at the aircraft is off to the left. I missed, it's not right there. But all these sort of white tents are very, very strange and wonderful. And that's my story, and I'm sticking to it. There you go. So Nathaniel, you want to tell what we learned?
What we looked at?
Yeah, let's see. Or what did we learn there? Or do you wanted to show the picture of the Southern Hemisphere super darns?
Sure. I have an eye chart I can show everyone. Let's see. It is JP's poster. So actually the cedar posters handy.
Yes, that would be good.
Okay.
We're very proud of this particular student for making the software actually work.
Right. Okay. Got that. So in addition to going to Boulder, we went to the CEDAR conference in San Diego last week, and the same 4 students who went to Boulder also went to CEDAR. So this is a poster from the CEDAR conference, and JP Fox, he was able to take my code, which detects MSTIDs, medium scale traveling atmospheric disturbances, and the super darn radar in the northern hemisphere. And he ran it also for the southern hemisphere. And so this is a whole solar cycle, 12 years worth of observations. And the top plots are of the northern hemisphere. And there are a few that didn't quite make it onto this poster, but he does have a new version of the poster where they're filled in now. The top plots show the MSTID activity in the northern hemisphere, and the bottom plots show it in the southern hemisphere. And so now what we have to do is we have to go through these and make sure that they're actually telling us what we think, what we hope they're telling us. And then we also need to understand the climatology that is being presented here. So we have quite a bit of work to do, but we now have some data to work on, which is quite good.
Do you want to say something about why the bottom most row is so sparse?
Sure. So in general, the southern hemisphere tends to have fewer radars, and it also the type of radio propagation that we're looking for here, it works better in the northern hemisphere where there's ground versus the southern hemisphere where there's ice. So you tend to get more sparse data in the southern hemisphere. But you'll notice that these last few years are even sparser than usual. And there's I think there's at least two reasons for that. One reason is I think the solar cycle. So we are going into maybe a lower part of the solar cycle over here. But the other reason is that this is right around when COVID started. So over here. And so COVID should not be affecting radars that operate automatically. But it turns out that the radars that operate automatically, sometimes they break down or need to be fixed or things like that. And when COVID was going on, there was no travel. Travel was not allowed, and people couldn't get out and fix the radars or collect the data. So we think that's another major driver of why there's significant data gaps down here.
Or it could be that we did not realize that COVIDs could also affect radars and make them sneeze and whatnot.
That is possible too. So yeah, less data there, definitely more data up here. So each of these plots, it's 12 months of data along the x-axis. So every column is 1 day of observations. And then on the y-axis is 24 hours worth of time. So you can see both daily and seasonal variations in there.
I seem to recall, I'm not sure whose presentations it might have been over the last couple of years, but talk about the seasonality in the LSTIDs in the past, right? What Mary Lou showed was pretty interesting, but it's not the first time we've seen that, right? I think
Yeah, so I saw seasonality in MSTIDs using the super darn data when I was working on my PhD. And I saw that there were more in the fall and winter and less in the spring and summer. And that every once in a while you'd have a few weeks at a time that would just drop out. And that corresponded with the polar vortex breaking up. And so now we're still looking for those patterns, but we're trying to see them in the southern hemisphere. Before we just looked in the northern hemisphere. So now we're trying to see the same sorts of patterns in the southern hemisphere. We're also trying to see them in larger scale traveling atmospheric disturbances as well.
it's interesting for a lay person such as myself to sit back and kind of watch this process of how you guys, share ideas and whatnot at all these conferences, and how some of these things are starting to kind of, at least in my mind, starting to fit together a little bit. So it's exciting to watch.
Definitely.
I thought it was also interesting in this conference to hear people talk about the different instruments that they use to measure things. So a whole bunch of these people use data from satellites, and they talk about looking down at the Earth or looking down at the atmosphere from this or that sort of vantage point. and using different kinds of instruments to measure temperature, pressure, electron density, other sorts of things about the atmosphere, which to our eyes just looks clear going all the way up. But I thought that the instrumentation was interesting.
I absolutely agree with that. There's a lot of different ways to look at the different parts of the atmosphere, and they each have their advantages and disadvantages and their strengths and weaknesses. And so trying to use all of them appropriately together to create a good picture is really important.
Right, and each of these instruments on each of these satellites or whatever tells you something or a combination of some things about the air. And so sometimes you get temperature, sometimes you get a velocity, sometimes you get a direction to the velocity, which is really nice. It's going eastward at so many kilometers a second or an hour. Other times you have to try to, they have to try to tease out, well, if this changed to that, and it meant that this parcel of air was going up in the air, or if it changed to something else, it was coming down in the air, and how that affected things, because the layers are very different as they go up and down. So it was exciting. And we clearly don't know an awful lot about the atmosphere.
Mm-hmm.
So we're very happy to have anybody's help at all.
So my takeaway from some of this is I think Joe Huber is going to be a busy guy for the next few years, because I can just imagine the wheels spinning in his head as he tries to improve his models with all these things that you're finding out and demonstrating and whatnot. So I guess good work in that respect, because we all hope to have better models in the future, and I'm sure we will.
All right. Right.
And better data processing too. I'm very busy working with Mary Lou and Bill Engelke and that team, trying to look at this RBN PSK reporter WhisperNet data and trying to come up with an appropriate way to automatically tell people, is the bottom of here, do we see a disturbance moving through the bottom or not? And it turns out that that's a tricky problem, isn't it, Mary Lou?
Yes, yes, it is.
So we're trying very hard to figure out an appropriate way to do that.
Can you go back to what was the good one? 9th of November,
Yep,
the pretty one.
couple of good ones, but that one is
Yeah, isn't that pretty? Look at that top
Wow.
picture. Can you say wave?
there's definitely a wave there.
Yeah, yeah.
So with this, what we're doing is Nick Callahan at Alabama figured out how to take this heat map here, and then he can draw a very nice blue line on the bottom. So that blue line is automatically drawn. So now I'm trying to take that blue line and trying to say, can we come up with an automatic procedure to tell you whether or not there's a wave structure in there or not? So I've done a couple of things. I took the blue line and then I filtered it. And so here's a filtered version of the blue line. So the orange one is now filtered. You can see it here and you can see it back on top there. And then what I did was I took the Fourier transform of that orange line and I looked at it. Here's the this orange, that light orange curve there is the Fourier transform of the orange line. And then this dark orange one is one where I've just removed the background trend of the spectrum. And we're very interested in this period that's shaded here. This has a period of between 1 to 4.5 hours. And so that's what's shaded over here. And then this is the same thing as up here, just zoomed in this region. And so I'm looking for peaks in this shaded area. I'm also taking all the values inside the shaded area and adding them up and trying to use it as a way of detecting whether or not there's wave activity here or not. And it's not, it's working marginally, not super well. So I'm spending a lot of time trying to figure out how can I make this better.
Yeah, it's fascinating. That's interesting though. I'm having trouble getting any information out of the Fourier transform view of that, but we'll get into that some other time, I'm sure. That's interesting though.
Yeah. Well, admittedly, I'm having trouble getting information out of it too.
Okay.
So if I weren't having trouble getting information out of it, I'd be much happier right now.
He'd be writing another paper.
It looked good. Is there a reason you took WhisperNet for this analysis over other two datasets?
We actually have all three mixed in there.
Okay.
That may or may not be the most appropriate thing to do. But for this analysis, we just put all three of them in there.
Okay.
Down on this bottom plot here, the blue is my number that I added up the spectrum amplitudes within this gray region. And then the green is where Mary Lou said that she said how many hours per day she saw a TID.
What is a TID?
A traveling ionospheric disturbance.
One of those wavy things. So, and the black part is just where they overlap. Is that it?
That's right.
Okay. So I thought that this was at least encouraging.
Mm-hmm.
There are some places where there's white lines, which means we both agree that there's nothing there.
Mm-hmm.
And there are other places where there's tall green going with tall blue, and that's nice.
Yeah, I agree with that.
But then if you plot the green against the blue, you go to the right, and there's a scatter diagram. And I could be convinced a little bit that there is some sort of upward trend here, at least the bottom envelope that goes up with a nice trend. But then
I
there's all
agree.
this smushes stuff in the upper left that doesn't seem to, you really like a line.
Yes.
No real line. There's a line and then smush.
Right.
But I thought the line at the bottom was nice.
The line at the bottom is nice.
Kuldeep, what do you think?
Yeah, it looks good. As if we have the bottom envelope.
Look, but go to the graph.
Yeah.
That one, stop.
Yeah, the bottom looks good. And then,
We'd like to get rid of that 1 point right there, right? That one?
yeah, this one.
Yeah, take him away.
Yeah.
So, Gary, when one is looking at data of this sort, where you're not really sure quite what's happening, when I looked at that graph, I thought, yeah, I see a nice line there, but there's that 1 point. So I would then find what that point was. Can you tell the date of that point?
Not easily.
So you might look for some another anomaly or, an X-ray flare that day or some such thing that may have caused.
That's called an outlier.
Yeah.
Mhm.
And you look at the outlier and you say, what was its real problem? Oh, that's the day that the sun blew up or whatever.
Because there are a few that do have real problems.
But I mean, that's the sort of thing that then would catch your interest, and you'd ask, why was there some other problem on that particular day that would cause it to be too low or too far to the right from what it should be? And we know from radio observations that there are days when things happen, like there are solar flares and things like that. So
Yeah, this is kind of an unusual day where you have
Yeah.
the data mostly over here and then it really comes down in close.
Mm-hmm.
Oh, was that a contest day? That could have been a contest day.
Yeah.
Sounds like Candace Bergen.
Oh.
January 9th, 29th.
It could have been the North American QSO party. That's usually early January.
January 9th, I think, is the weekend of the RIDI Roundup.
Ah, okay.
That's possible.
That's why you folks are very useful.
I was going to make a wise remark about Elon Musk and launching more Starlink satellites on that day, but that's probably not true.
Oh, and here was a good day. That one. Whoop, go back. Yeah, what happened there?
This is the day Anthony was born.
Really? Did he do that?
He must have.
Oh my golly.
Where you blackout?
Trying to get yourself
Clearly
on
something wrong with the
control that
system there.
nurse so we can get Lita to do both of us.
So why was there a blackout on January, what, 19th?
Yeah. It's also unusual that if this is combining all three data sets, Whisper, RBN, and PSK reporter, why all three would disappear?
The sun was doing something nasty.
Now,
Right?
it looks like there's a data problem.
For 3 hours, it is unlikely from the sun point of view. Yeah.
It's very unlikely to have absolutely zero data points.
Yeah.
I mean, that seems very strange.
And certainly one needs to look into that. Yeah.
Mhm.
But I remember in other years when Diego and I were looking at things, there would be shorter blackouts, maybe for only 1 hour or so. And those were always due to a solar flare. So you looked up the solar output and go chig chig woo, and that was when the blackout happened.
Yeah, I would believe that, but
How long was this blackout? It was for several hours, yes?
yes, several hours. About 2.5.
Okay. Oh, something. So sideways here. I would like to ask Gary about, but something that I think is interesting for this group is I would like to get into what about sporadic E? What does that have to do with? And one of the papers I read about that recently had to do with a group using a radio telescope, basically a big radio telescope, and listening to the radio noise from the local power grid. And the local power towers are going bzzz, and getting that reflected off of sporadic E patches could be detected by the radio telescope, and they were not happy with it, but it was a way to measure sporadic E. So that's there's no.
I think that's right. I mean, you've raised that question about sporadic E, so have a few others. So I think I'll talk to, we'll try to stir some interest in that subject and get somebody to speak on it in the next couple of weeks. That'd be great.
So does anybody know who would be good to tell us about sporadic E? There's Joe Dekovich, but anybody else? Nathaniel, who would be good for sporadic E?
Has Carl Lutzelschwab done much work in that area? I'm not sure.
He's done some. Steve Kepler is always interested in sporadic E. Gareth, do you know any good sporadic E people?
Yeah, Steve Kepler comes to mind. Alex Chartier has been barking up that tree. Bharat Kunduri as well.
Mhm.
I'm trying to think. Aro at Embry Riddle as well. Yeah, there's a few in the community. And I know specifically Alex Chartier has been doing some work on ship to ship communications, because that it's up in the VHF band, but I think it's more like 2 meters or something like that. And there's been all these anecdotal loggings of ship to ship contacts that are well over the horizon. And so he's been trying to kind of link that to sporadic occurrence. So, yep, there's people around.
So where is Alex located?
Alex Chartier, he's at Johns Hopkins, APL.
Are the people on the ships suddenly surprised that somebody is talking to them that they didn't know about, or
I don't know quite the way it goes. Like, I don't know if it's it's like it's a logging system. I'm not too familiar, or if it's just they don't. I don't want to say they don't appreciate, but it's just something that they have, and then that's not of interest to them, but it's of interest to a space physicist. So
and they write it down, or it somehow goes into the log, huh?
I think they have a system that logs it in an automated fashion of some sort. I, Honestly, Alex gave a presentation about it, and I was, in my high conference form, which is half an ear on the presentation and half an ear on making the presentation I'm about to give, kind of thing. So
Yeah, right.
so I should go back and see the slides, or bug Alex for the slides.
So could we ask him to talk about it? That sounds interesting. I don't know.
I think so. Yeah, I think he'd be willing to talk about it.
I was
From the
wondering
UK,
Would you like me to reach out about?
Sure.
Yeah, I can reach out to him. Yeah.
from the UK, it would be Chris Deacon, who gave a talk on why 6 meters and sporadic E is so weird at the HamSCI in March.
Yes, could we hear that one again? That would be good.
So I could reach out to Chris to participate. And what there is as well is an awful lot of historic data in the Whisper database for Europe, which can be a nice test bed of concentrated 50 megahertz activity at a time. I mean, I did have a go a few years back and produce this sort of animation. So every 20 minutes, the receivers 50 megahertz are in green, transmitters in red, and the midpoints are in blue. And the diameter of the midpoint circle is related to the number of spots per 20-minute interval. So small diameter, one off, whisper spot, large diameter, many spots within the 20-minute interval. And but you've got to watch the time on the top right, because it does jump. But you can see appear and disappear, and how long they last for and where they are. And you do get crossing paths, which is useful given the scale of Europe, and the density of stations involved. You might convince yourself there's 2 clouds there, for instance. So there's lots of historic data that one can already mine.
Interesting. Well, if we can reach out to a few of those
Yeah.
people and get a few of them on the call in the next couple of months, I think that'd be very appropriate and very interesting. Any questions for Mary Lou and Nathaniel on what they presented today, which to me it hits right at the heart of why we do this call. It's fascinating information you guys brought forward. So, and there's more to come too. That's the best part of it. So, don't have all the answers yet, right?
So can I show you something else?
Sure.
Okay. So two things. First, I sent along a Word document, or Gary sent it out, about how to analyze these data. And it's things that I had in a PowerPoint, several different PowerPoints, and I've now put them all in a single Word document and changed some of the stuff at the end to make it easier. At any rate, I would really like to have people look at those RX888 and other personal space weather observations, the green plots, and send me some data. So I've got some people, I'd like more people. If everybody could do 3 of them or even 1 of them or something and send it to me, either in the spreadsheet form or, and I should send out the spreadsheet so far, at least the one that has me and Gary, our stuff on it, and or just send it in text. You know, these are the numbers, because there's a lot of data there on the eclipse day, and between what do we have on me and Gary? I don't know, 50 different observations, but there's hundreds, and I really think we need lots more data in order to get rid of to get some lines and not too much smush. But anyway, to look at the bottom of that and see if you could do that. But anyway, so one of the things I thought to do that's related to that, but a little different, is to take the pictures, take the green graphs, cut them up and rearrange them. I'm great at cutting up stuff and rearranging it. I don't know if you know, I'm a quilter. So I take perfectly good cloth and I cut it up into little squares and then I rearrange it and sew it back together again. And then put a backing on it, and it's nice. But people think this is very strange sometimes. At any rate, I'd like to show you Nathaniel's observations cut up and redone. So I'm going to share my screen, this one. So here's Nathaniel's data from the RX888 on eclipse day. And so what I've done here is rearrange them, cut them up and rearrange them. The top 3, which are the smaller size, are for his observations of CHU in Canada, and they're arranged in order of increasing frequency. So there's 3 megahertz, 7 megahertz and change, and 14 megahertz. And then below that are the ones where he is measuring the stuff from WWV out in Colorado. And again, these are now arranged in order of frequency. So we have 10, 15, 20, and 25 megahertz. And what I thought is interesting to do to this, and I'm going to do with all the other ones that I have that are 8 at a time like this, whatever. Yeah, this to look and see how strong the signal is. And so it would look to me like in this part where he's looking at WWV, that the top 2 are really nice and strong. And then when we get down to the bottom for 20 and 25, they look kind of wimpy. And so something is falling off in the intensity there of those 2. So something between 15 and 20, there was a change. And then we go up and look at these, and we don't go to between 15 and 20. We just go to at sort of 15, and there's nothing above that. So at least I make a note in my my examination of these particular ones that something happened between 15 and 20 that should be looked at later. Did anybody else see that? Was that?
Yeah, I suspect, Mary Lou, that the 25 megahertz at Nathaniel's location could well be 2 hop side scatter. I mean, I've looked at some of these at AC0G, not Nathaniel's location, in some detail. And I think what's really useful to have alongside the spectrograms are the amplitude plots, because the color scale is auto ranging. So I think you'd find that the amplitude on 25 megahertz is also way down compared to the other frequencies. And also the width of the trace there in the gap, sort of either side of 2000 UTC, is fuzzy. So the spectral width for that Doppler profile is greater than on, say, 10 megahertz or 15 megahertz. And so I strongly suspect that that is 2-hop side scatter at 25 megahertz.
Great, that's what I wanted to know. Now say that again. So
Sorry?
I understand it.
So on 25 megahertz is likely to be above the maximum usable frequency for the path from WWV to Nathaniel.
Now, yes, that's what I thought you said. Now, question then. All right,
So
so
that
between WWV and Nathaniel,
yeah,
25 is above the muff. All
yeah.
right. If I looked at from WWV to Illinois, would we likely have it above or below the muff there? How does it go with distance?
The shorter the range, then the more above the MUF it would be for that range. So it's likely
So
that
if we took a shorter range, how would we expect the picture to look different from what I see now?
maybe even no 2-hop side scatter for the shorter range, perhaps. So in the 2-hop side scatter, the signal from WWV would have propagated out to a greater distance than between WWV and Nathaniel, and then it would have been scattered back to Nathaniel's location, and of course all others.
So what I think I heard you
so
say, is this right?
I think it's probably best that I take a little action to do a 1-page slide for a future talk, for a future evening, where I can show what's likely happening for this particular instance.
Gwen,
That's
why
probably the best thing to do.
why are you saying that it's side scatter?
Because it's likely for the distance from WWV to Nathaniel at that time of day that the 25 megahertz is above the MUF. And so rather than having a direct 1 or 2-hop path from WWV to Nathaniel, it's within the skip zone. But you still see that Doppler shift because there has been 2-hop side scatter. Okay, where the signal has reflected off the ground on a non-great circle path and come back.
You mean it bounced off of Maryland or somewhere?
That's why I'd have to do, and what I do on this is to use 3D ray tracing, courtesy of PyLab, courtesy of Nathaniel and his group, to look at the intersection of the ray landing spots from WWV, and then assuming reciprocity, putting a transmitter at Nathaniel's location and see where those ray landing spots coincide. And that's likely to be the ground scattering region.
Now you've hit a point for me because I don't assume reciprocity at all.
Well, it's about the only thing you can make the problem tractable at an amateur level.
David, what would you assume, or what would you do to try to figure this out?
Well, that's a good question. He says, as Gwen says, amplitude is all important. Now, of course, I'm a little bit further from WWV in New Hampshire, and at least until the Mother's Day storm, I was getting 25 megahertz during the day, S9 plus. Since the storm, my 25 megahertz has pretty much disappeared, which is also very interesting.
Where'd
But I
it go
would,
to?
for where I am, though, being a little further away, it would have been probably a proper skip. But yeah,
There's,
do you know that Nathaniel is in a particular no skip zone, Quinn?
As I think I sort of said that I suspected this. It's probably best that I do the ray trace modeling and come back. It will be far more definitive.
That would be
Good.
very interesting.
Yeah, could you
Now,
do that?
I will
Yeah.
also point out another way to help figure this stuff out is to actually have time measurements, but we don't have that in our current receivers.
No.
well, in my experience, this is also possibly backscatter. It's well known, particularly on 10 meters, when there's minimal propagation east-west, you can both aim your antennas over the South Atlantic and converse that way. And the signal bounces off something in the South Atlantic and makes its way across at least half of the US.
That's called plasma bubbles.
Well, I've always referred to it as backscatter.
Well, what I'm saying is they're plasma bubbles and a lot other things that happen over the equator that you very definitely can get odd propagation from.
Have you ever done that, Dave?
I have not done it, but I know of it. I also know that there's very strong propagation from north to south hemispheres because I hear Brazil and further south all the time.
Yes, trans-equatorial propagation, I believe that's the term.
Correct.
Can you speak Portuguese or do they speak English to you?
They speak English a lot more than we speak Portuguese.
Use
And
Morse
IT
code,
use Morse code, so it's all
doesn't matter,
abbreviation.
or FT8.
There you go.
The only Morse Portuguese that I've heard coming from Brazil that I halfway understood, so to speak, is on the 10 megahertz time channel. That's how I identified it was coming from Brazil.
Okay, we're getting near the top of the hour. We've had some very interesting discussions today, and we've definitely got some follow-up. I think, Mary Lou, I will point your document and some of your comments today toward the HamSCI grape reflector as well, because there's a lot of people there that should be very interested in what we're trying to ferret out here. So another good group, and then to see Gwen's slides and ray traces in a future meeting would be wonderful as well.
Yeah, I really like the ray tracing. I just think it's beautiful. I've been blessed with another 100 of these cards, and I'm giving them out to people I meet. So sometimes I meet somebody, so I show them this and I say, you know somebody who's a ham radio operator, would you give this to them? And they say, sure, but can I have another one just for me because it's really pretty? And other people will say, no, I don't know any ham radio operators, but can I have one because it's pretty? So I'm really pleased with your artistic work on these things. So got to think about that. All right.
By the way, if anybody wants to work thunderstorm skip, we got plenty of them right here.
Is it raining right now? And
I'm on like 4th storm going over today.
so how does the storm make things better for the radio? You say?
Well, it's highly ionized. And I know that I used to do a lot of FM DXing, FM broadcast. And one of the best ways to get DX is off of a underfront.
Mm.
Very strong ducting.
Okay, well, everybody go out and do that then. Thank you very much. See you next week.
Thanks, everybody.
All right, have a great week, everyone. Talk to you next
Yep.
week.
Thank you.
Bye-bye.
Bye-bye.
Don't fly any kites.
73 all.